understand is, first of all, when we come into complex numbers, x squared plus 1 equals 0, right? You solved, x squared equals -1, square root, x equals plus or minus the square root of -1, right? So what we need to understand, just like imaginary numbers, when we have our I as a 0, the complex conjugate exists, all right? So whenever we have I as a 0, the complex conjugate exists. And what that tells you is, right, you can't just have I by itself. It's always, we got I by doing square root of plus or minus, right? So if there's a positive I, there's always going to be a negative I. If there's a negative I, there's always going to be a positive I. The complex number and its conjugate are always going to exist in the polynomial. Yes?
What's a complex conjugate?
Complex conjugate, one example, if we have A plus BI, the complex conjugate of that would be A minus BI.
What makes it complex?
The complex this is what we call the complex number. The reason why it's a complex number is we have a real part and we have an imaginary part. And the imaginary part is imaginary because we have the imaginary unit, I. Okay, did you have the notes from that day? Were you here, or were you at that Sunday? Okay. Because I know a whole bunch of students missed that class and over there. So you just need to make sure you know those, at least the definitions for in there. So what does this tell us? Why is this all important? And really the main important thing you guys just need to know is, which I can break this down, seriously. All I need to do to break this down for you guys is just write, if you have x equals plus, if you have positive 3i, therefore your zeros need to include x minus 3i. Alright? So rather than going through that long description I said, if you guys just see an I and it's positive, you need to make sure you include the I with the negative. If you have an I that's going to be negative, you're going to include one that's going to be positive. Okay? So, there's now our conjugate. So now, we can write these all as, well these are written all as zeros. Now let's write them as they're factored equal to 0. So we're writing x minus 3i equals 0, x plus 3i equals 0, and x plus 1 equals 0, right? And we got to these by using, now if we use reverse zero product property, I can say that this polynomial right? We got to that point by using the zero product property, and we solved that from each one of those factors. But we're not trying to set it equal to 0. It already was set equal to 0. We want to determine what is this polynomial. So now we have to apply FOIL. All right? And what's nice, remember those problems on our homework 2 nights ago? Remember those problems where it says multiply the number by its complex conjugate? Yes, and I even did an example in the class. You take a number, you multiply it by its complex conjugate, it should be the same factor problem that you talked about today, which was called a difference in two squares. This is the factored form of difference in two squares. So to multiply this out, you guys should know that the middle terms are going to eliminate or add to 0. I can just multiply my two outer terms. So x times x is x squared. Negative 3i times 3i is going to be a negative 9i squared. And we'll get through the I squared in a second. I'm going to keep on moving back and forth. Then we have this times x plus 1 equals f of x. Well now, obviously, ladies and gentlemen, we know that I squared is negative 1. Negative 1 times negative I is just going to be a positive 9. Right? So now we have x squared plus 9 times x plus 1. Can we now apply FOIL or the box method? Right? I like, when multiplying these, I like to apply the box method. It just helps me organize everything. So I write one binomial up here, and I write the other one on the side. You can apply FOIL. FOIL's cool. I like FOIL. I also like this though, because it just keeps everything organized. So when multiplying, I just multiply the length, or the lengths to find my boxes. X times x squared is x cubed. X times 9 is 9x. X squared times 1 is x squared. 1 times 9 is 9. Therefore, my polynomial, I'll write the f of x first. F of x equals x cubed plus x squared plus 9x plus 9. Okay? Okay? That was confusing.
I said that wasn't
Oh, no. The next one is though. Sure.
That wasn't
So,